Okay, so this is a question about electric circuits. It might be worth pausing the video here so that you can have a go at this question yourself, and then we'll go through it together. Okay, so we're going to have our trusty highlighters as usual so that we can highlight key information in the question, and then I'm going to annotate some bits and bobs as we go through it. So, a student set up the electrical circuit shown in the figure below. Now I know that the instant thing might be to jump straight to the questions, but always look at your diagrams first. So we can see here, this is labelled 12V, so this power supply is a 12 volt power supply. I can see that there's an A in a circle, which I know is an ammeter, an R with this rectangle, which I know is a resistor. This rectangle, which again I know is a resistor, is labelled 60, and then this sign, which I know is ohms, so it's an omega symbol. So this is a 60 ohm resistor, and this is a 45 ohm resistor. And then there's this switch in this kind of parallel bit here. Okay, so the next part of the question tells us that the ammeter displays a reading of 0.10 amps. So actually I probably would have highlighted the data that you're given in the question as well. And then because it says the ammeter displays a reading of 0.10 amps, I'm actually going to label the ammeter with that value, because otherwise I might forget later on. So then it tells us to calculate the potential difference across the 45 ohm resistor. So the potential difference across the 45 ohm resistor. So let's think about how we're going to approach this question. Because we've got three resistors that are connected in series. So this is a series circuit. Okay, so we need to maybe remember our circuit rules for series and, well, just for series, sorry, for potential difference and for current. Sorry, that should be an I, not an A. Okay, so the rule for current in a series circuit is it's the same everywhere. Okay, so therefore I know that if it's 0.10 amps here, it's 0.10 amps here, which means that it's also 0.10 amps here where my 45 ohm resistor is. So that's why it's really important to think, what do I know about this circuit? What is the physics behind it? And then I know that for potential difference, if current is the same everywhere, then for potential difference, it has to be divided between the components. Okay, and that it will add to make the same voltage as the power supply. Okay, so we'll probably not actually get that far because we don't need to, but it's always worth remembering these rules. Okay, so calculate the potential difference across the 45 ohm resistor. So in this resistor, I know that the resistance is 45 ohms, and I know that the current is 0.10 amps. And then what I'm being asked for is the potential difference, which is V. So I need to think about what equation can I use that has those three things. Well, I know that V equals IR, and that's an equation that you need to learn. So I is 0.10 amps times R, which is 45 ohms. So if we get the calculator, 0.10 times 45 gives us 4.5 volts. So as usual, always make sure you write it in here, because then it makes it really clear to your examiner where they're going to give you the marks. Okay, so the next bit we know is going to be slightly more complicated because it's worth 3 marks. So we need to think about this perhaps in a little bit more detail. And this is saying calculate the resistance of the resistor labelled R. Okay, so let's just go back to this bit of information here actually. What do we know about resistors in series? That they will add up to make the total resistance. Okay, so that's the first thing that we need to do, because we've got 2 out of the 3 resistors, we've got the values for those ones, and to work out the third one we need to know what is the resistance of the whole circuit and then take away these 2 resistors. So the total resistance is going to be the total potential difference divided by the current in the circuit. So the potential difference of the power supply, 12, divided by 0.10. So if we do 12 divided by 0.10, gives us 120 ohms. Okay, so that's the total resistance. And then to find R, we're going to do R equals, so that the total resistance take away 45 plus 16. So that's 120 minus 45 plus 16. Okay, so 45 plus 60 is 105. So if you do 120 minus 105, then that's going to give us a resistance of 15 ohms. Fabulous. Okay, and then the last question. State what happens to the total resistance of the circuit and the current when switch S is closed. Okay, so let's look. This is switch S, so this part here. So the total resistance of the circuit and the current through the circuit. So it's giving it to us in that order, total resistance and then the current. So let's think about it like this. We've effectively added this branch in parallel. Okay, so if we add a branch in parallel, then we're opening up another pathway. Okay, opening another pathway. So if we're opening up another pathway for the electrons to go, then we can say that the total resistance decreases. And this is something that you need to learn about parallel circuits, is that when you add another branch in parallel, that the total resistance will decrease with each of the branches that open up. So the analogy that we always use is, if you're in a supermarket and there's a big queue of people who are waiting to be served, if they open up another till, then people move through more quickly. So that's like having another till opened up and another one that everyone's going to move through quicker. It's not a perfect analogy, but it gives you a little bit of a way to think about it. So therefore, if the total resistance decreases, that's the total resistance of the circuit. So what's then going to happen to the current? Well, we know that resistance is used or controls the current. So if we have a high resistance, that's going to reduce the current. So therefore, if we decrease the resistance, then we can say that the opposite will happen to the current. So the current will increase. And so that's our 2 marks, really, is for saying the total resistance decreases and the current will increase. So this first point isn't actually going to score you any more marks, but it's just my way of kind of getting you to think about the actual circuit.